All right, guys, we're doing quadratics, quadratic equations, functions, zeros, and maybe even some models. So here we go. Quadratic equations look like this. Quadratic means there's an x squared term. X squared plus bx plus c, that's the standard form of a quadratic equation. Quadratic functions, basically replace 0 with f of x. F of x makes it a function form. A, b, and c are real numbers, just like they were above. Looks exactly the same except for f of x for the 0. Ways to solve equations with these things. Two ways basically we're going to go about this. One is we're going to try to get them factored. If we can factor and have two factors equal to 0, if that's true, that means either a is 0 or b is 0, or maybe they're both 0. So what we're going to try to do with them first of all is factor them and then set each factor equal to 0. If we can't do that, we also have a principal square roots where we can get the square on a side by itself, take the square root. When you do that, we're always going to put plus or minus in front of our solution. If you look, we got x is k, x is negative k. Always going to put plus or minus in front of our solutions when we take a square root inside an equation. All right, let's try one here. This is 2x squared minus x minus 3. Anytime you start to solve one of these, the best thing you can do almost all the time, with the exception of one time I can think of, is get everything on one side equal to 0, like that. And what I did is I want to show you the graphing version of that answer. So what I did is I punched it in a calculator and, and graphed it and got a parabola, which all quadratics give you parabolas. And your answers to a quadratic, just like any other thing, are the zeros of the graph, or the x-intercept. So you cross the x-axis at 1.5 and also at -1. So the two solutions of this equation would be x equals 1.5 and also -1. That's what the graph looks like. Now, what we would probably solve, instead of doing all that work on the calculators, we'd go ahead and do slide, divide, slide, and factor it. I'm going to go ahead and just make it real quick for us so the video will be faster. If I do slide, divide, slide, I would get right there. And my two solutions, obviously, this is what I was talking about a second ago. That factor times that factor equals 0, which means as long as one of the parentheses is 0, the whole thing is 0. So my answer would be -1. And this parentheses, what would make it 0 would be 3/2, which is exactly the same thing as the 1.5 on the calculator. So, two options there, not options, but two ways to look at it. One algebraic option, just factor and get your two answers. The other way is, you can graph the option. The graphing option where you find your x-intercepts. And you got to be careful there because it don't work every time, and you're about to see why. Let's solve this one. This is the second method that was on the first slide, and that's taking square roots. So what I would do here, if you want to factor out the 2, you can. That may not be a bad idea. Let's divide everything up there by 2. So I'm going to take a 2 out there, 2 out there. And if I take a 2 out of 0, it's still 0. Let's move the 5 over. Can't factor x squared minus 5, so I'm going to move the 5 over like that. Take the square root. That's what the second method was on that first slide was, okay, if you can't factor it, we're going to take the square root. So don't forget, though, if you take the square root in an equation, you need to get two answers. You got to get plus or minus in front of your answer. I can't break down 5, so that's it. Just plus or minus square root of 5. All there is to it. Right now, here is some good information when you graph these. Remember, we talked about every single graph is a parabola if it's a quadratic. One case you may get is one like this one, and there's your equation I have. You can see the x squared minus 3x minus 4. And I graphed it, and it had two x-intercepts, which means there's two answers, two zeros or two solutions. However, what if one looks like this, x squared minus 6x plus 9? What happens on that one is it does touch the x-axis, but just at one place, 1 point. So the answer to that one would be 3. X is 3, solves that, or the 0 would be 3. The other case is, what if the parabola's up here, or below it, and opens down, but there's no x-intercepts at all? If that happens, that means there's no real zeros, which means your solutions are going to be imaginary. So you're going to have eyes in your answer if that's the case. So 3 kinds of answers, either no solutions or no real solutions, means there are 2 imaginary ones, 1 real solution on that one, or 2 real solutions on that one. All right, find the zeros of this one by completing the square. I hope you remember that from Algebra 2. If not, I'm going to show it to you right now. Also going to give you a gesture for it tomorrow, which will really help you, I think. I think it does. So x squared minus 6x minus 10 is 0. When you complete the square, you want to move your constant term, which is the 10, to the other side. And then what you do, the steps are these. You take half the middle term, which would be -3. You square it, which would be +9, and you add it to both sides. So you take half the middle term, you square it, add to both sides. Over here I now have 19. On the left-hand side, the reason we did that is so I could factor this side, and it would be x minus 3, or x minus 3 squared. And once you get a square like that, like we did a minute ago, you can just take the square root of both sides. And when you do that over here, the square goes away. On the right-hand side, don't forget you put a plus or minus in front each and every time. And the last thing you do to get x by itself is you move the 3 over. So you get 3 plus or minus square root of 19. There's your solution right there. And that's how your answers are going to look a lot today. Kind of like that. So don't let that bother you. That's just how it is. So complete the square. Half the middle, square it, add to both sides. Then take the square root and finish it. All right, solve this one. I'm going to complete the square here too. This is going to be a little uglier because there's an odd number. And I'll be honest, this is probably the only time I ever do one of these with an odd number because there's a better way to do it with an odd number. And you'll find out here in a second. I'm going to move the 3x over because I want it to equal 0. I'm actually going to take the 1 over there too because I'm about to complete the square. Now the problem with completing the square on this one is you're not allowed to complete the square when you have a coefficient with your x squared. So what I'm going to do is I'm going to divide every term up there by 2, make that 3 halves, make the 1 1/2. Now I'm going to complete the square. Watch how crazy this looks. I'm going to take half the middle term. Half of 3 halves is 3/4. And if you're not sure why, I will tell you that tomorrow, but it's just fractions. It's taking half. Think about multiplying 3 halves times 1/2. You just double the bottom. So if I'm going to square 3 halves, which gives me 9/4 and 9/4. Right, on the right-hand side, if you add 1/2 and 9/4, 1/2 is really 2/4, which gives me 11/4 over here. On this side, you can factor now, and if you haven't figured this out yet, whatever your half, that's why I write this up here. Whatever the half was always goes inside your parentheses, and it's squared. So I can now take the square root of each side, which gives me over here the square just goes away on the left. On the right-hand side, don't forget your plus or minus, square root of 11. Now, I don't know the square root of 11, but I do know the square root of 4 is 2. So my solution is going to be move the 3/4 over, 3/4 plus or minus the square root of 11 over 2. And that's all there is to it. That is pretty tough one, I'll be honest with you. And we're not going to do many where you have fractions in there like that because I think there's a better way to do it, and it's coming up here in a second. It's coming up right now, the quadratic formula. This is the best thing to do when your middle term is odd. You can't complete the square, you can't factor, and it works every time. It actually is the formula for completing the square. That's where it comes from. It comes from working out this equation right here by completing the square. And if you're interested in that, I will show you that in class tomorrow. But you need to know the formula. There's a song that goes x equals negative b plus or minus the square root b squared minus 4ac all over 2a. If that helps you remember it, that's fine too. I can't believe I just sang the song for you, but we'll sing that tomorrow. Make sure you got it. Another way to solve them. Let me show you one. All right, solve this one by, we're going to do quadratic formula because I got that 2 there's kind of nasty. So do this first. Take the 7 over there like we've been doing. So I got 3x squared plus 2x minus 7 equals 0. And here I go. X equals negative b, which is negative 2, plus or minus the square root of b squared, which is 4, because that's b squared, minus 4a, which is 3, c, which is negative 7, all over 2a, so 2 times 3. Now, what I always do first is work out what's inside my radical. You can punch that straight in your calculator, but be careful. Make sure you use parentheses when you do that. 12 times 7 is 84. 84 plus what's 88 in there. And on the bottom I get 6. And I would be done, except for one thing. I can actually break down 88. 88 has something that goes into it. For example, 4 does. 88 is 4 times 22. So if I simplify that, break down that radical, I get 2 on 22 all over 6. That looks terrible. All over 6. Now, I would be done again, but I can cancel 2's out. So 2 goes into 2 one time, 2 goes into 2 one time, and 2 goes into 6 3 times. So you need to reduce it when you can. Always simplify. All right, that's the quadratic formula. One more thing. The discriminant. The discriminant is actually part of the quadratic formula, the b squared minus 4ac part that's inside your radical. And what it does, it tells you what kind of answer you're going to get. Anytime it equals 0, you get a 0 inside your radical, you're going to get one real solution. If it's bigger than 0, you get a positive inside your radical, you're going to get 2 real solutions. And if you get a negative inside your radical, obviously you're going to get an I, which means you're going to get 2 imaginary solutions. Or not actually going to be complex, they're going to be conjugates, complex conjugates, which we'll talk about. All right, one last thing here. Find the discriminant and then determine the number and type of roots or solutions exist for this equation. So first of all, move everything over, move the 8x over, move the 5 over. I guess technically you could move the 4x squared, it doesn't really matter. Now the discriminant, remember, is just b squared minus 4ac. So I'm going to take the b and square it. 8 squared is 64 minus 4ac. And work that out. 5 times 4 is 20, times 4 is 80. I think that's 144. And because it's positive, that means I'm going to get 2 real solutions. And there'll be different solutions, 2 real different or unique solutions. So that's all I got. A lot of stuff. You need to watch it again, go back, take good notes, and answer the question. See you tomorrow.